Hello everyone, welcome back to the channel. Sorry for the delay. I'm uploading this video very late because I was not well. But today I am here again. And thank you so much for watching my videos and for your support and for your love. Keep watching the Science Data Science videos. And if you need any help, please drop a comment. Okay. We are working with the data set of Brazil e-commerce data set. Okay. In my part one, I will just give you the small recap. Okay. In previous video, I have told you the goal. I have set the goal for this data set is classify the customer's sentiment. Okay. Like positive, negative, right? And neutral. So this is, we are working on this. Okay. We have created this target actually. Okay. This target we have created in our previous part one. If you missed that part one of the video, please watch that video. Okay. How we have created it. And then we did the data analysis. Okay. Of this data set. In this, you have learned like how you can merge the different data frames because we have so many CSV file in this, and then we start the data analysis, and then we have worked on the visualization. So this is we have completed in our part one, but today we are moving ahead in the part two with the model building. Okay. So this problem I have created based on the NLP text classification problem, right? This is a multi-class classification problem. So we are only using the two features from the given data set actually. We are not working on the using the all features for the model building because our goal is only to predict the sentiment of the customers. Either they are giving the positive feedback, negative feedback, or neutral feedback, right? Based on the given comment message. So we don't need any other feature for our NLP text multi-classification data like the goal or target. Okay. So we are going, I will show you practically which two features we are going to use. Definitely this one, this is our goal, which we have created last time. And the one more feature, review comment message. If you have already watched my video, then you should know what is that feature. Okay. And then today we are going to use the many different models. And in part three, we will work on the evaluation. The first model we are working today, random forest. Okay. So if you don't know what is random forest, I will give you the just like the definition, so you come to know what is random forest. If you're watching this video before watching the part one, it will make sense to you a little bit. But if you really want to learn from the scratch, you need to watch that video. So random forest is like a team of decision tree working together, right? So let's say this is your data, right? And it contains a different tree. This is T3, this is T2, this is T1. This is called decision tree. And whatever decision tree is like how it classify the your target based on the decision tree. Let's say this one says positive sentiments. This is also say positive. This is say negative. So majority of the like the vote is going to towards the like the answer positive. So your model will classify it as a positive sentiments. Okay. So this is the way how the decision tree works. Okay. And this is good. What is the reason why it is good? Because it handles a large data set as we have, because we have a 40 columns and we have a very big data set. We have a records in lakhs. Okay. And then it is also work, the random forest also works for the mixed data type very well. It is resist to overfitting. Overfitting. There is a no chance of like overfitting. Resist. Okay. And perform best among our models here. Okay. So this is very good. And the second model we are going to work today is LinearSVC. Okay, I did not use any other SVC model normal. I use a linear. The reason is this is fast and efficient. This is great for your classification problem, and it is also sensitive to feature scaling actually. Okay, so you need a standardization for this one. And a linear SVC, how it works, if you don't know, you can watch my playlist. You will find the detailed video on this. Okay, otherwise I will give you just a simple recap. It draw a straight line like something like this, and it draw the line something like this. Okay, and then it create the hyperplane too. Okay, it creates the hyperplane, and then it will classify the object. It's a positive, it's a negative, something like that. Okay, and then the third one is we are going to work today using the model logistic regression. This is also the very good algorithm for the your multi-classification or classification. This is very good, and this estimates the probability of the class actually. Okay, this is not straightforward positive and negative. It classify based on the probability of a class. Okay, this means 90% chances this is a positive class, positive sentiment. 10% chances this is negative. Okay, something like that, not in a numeric form. Okay, the next one is XGBoost. We have worked on, we will work on the XGBoost too. So XGBoost builds the tree one at a time actually, but this is a very fastest algorithm, I must say. Okay, here each new tree fixes the error of the previous one. Okay, let's say if you have the tree one, okay, this is tree one, it creates some errors. Okay, so your tree 2 will learn from these errors. T2 will learn from this error and then give the result. Okay, so this is very like a good model, and it is mostly used in the competitions. Okay, this is very good, and it is optimized for the speed and performance too. In our given data set, it focuses on if we talk about today, it's very hard to predict the customers and learns from the mistakes iteratively. Okay, but this model will work very good in this case. Okay, and like other one, this is very powerful and efficient. It often wins the machine learning competitions, and it can overfit if not tuned properly actually. There can be the chance. Okay, the next algorithm we are going to use today is AdaBoost. Okay, so AdaBoost also combine the weak learners. Okay, so this is, we also call it usually the shallow tree. We call it shallow tree too. This is focusing more on the mistakes each time. For example, if a customer with the rare delivery issue is misclassified, right, is misclassified, then AdaBoost pays a more attention to the similar cases in the next round. So I have just given you the layman example, this one. Okay, sorry. Why you should use this? This is like a sensitive to noise and outliers. Okay, and if you don't know what is outliers and noise, you can watch my missing value playlist. You will find over there, and works better when weak learners are just slightly better than the random guessing. Okay, so that's why this is very popular. Okay, and now this is the explanation, just the big picture about the your what big picture about the your today's part 2. Now we will jump on to the practical part. Okay, so let me cross this one, and then let me share my screen. Here we go. Okay, so I will give you the just here a recap, and I will show you if you are watching this video first time. Okay, and so you will have the clear vision what we are doing today. This is the data set, and the goal of the data set, as I have already mentioned, we are going to like classify whether the based on the given comment message, whether the customers giving the positive feedback, negative feedback, or neutral, no feedback. And I have divided it into three parts. First part is already done. We are going to do today this one. Okay. And we are working on the text model. Okay. So this is the biggest difference with the other, like the videos I have already uploaded. This is the first video which I am uploading, which where we are building the model, which is based on the text classification. This is not normal classification. This is the major difference. That's why I will tell you why I'm using only 2 features out of the total 40 features, although we have a big data set. Okay. Now look at this. This is the data set, and these are the different. We have the CSV file. Then I have explained how to merge them. I'm not going to explain it detail today. If you want to learn more about, you can watch my part 1. Okay, I'm just giving the recap. Here we are just started the analysis. You can see we have the here 1,15,609 entries, and we have the 40 columns. But we are not going to use all columns. We have used the columns, all columns, which is the very good for the visualization only, but not for model building. Okay. And then here we have applied some feature engineering method. Here we have handled the missing value. Why I have used the deletion method, you need to watch the video. Okay. So here we are clear. Then we have started the like the review sentiment insights. So this is the review sentiment and science. You can see we have created this so many graphs, right? And then I have showed the data visualization of time-based trends. So we divided it into different portions, right? And then geography and product behavior visualization. This is one. So you will have so much to learn from this video. Okay, so don't miss it. Watch that video. And now we are going to start today model building. Build the classification model. Again, we have loaded the data set. You can see here I have created this column. Okay, to create this target column, I have used the 2 features from these. That is the review, comment message, and review scores. You can see above in the notebook if you are going to download how I have created it. And then I have imported the files. This is pipeline because I love pipeline. It's very easy to pre-process the data. This is TF-ID vectorizer. If you don't know what is this, I'm not going into much detail in this. This is we use for the text analysis plus model building. Okay, you can just Google it, TF-ID vectorizer, how it works, because I have already explained it. Okay, in my previous videos. This is random forest classifier, AdaBoost. We need to import XGB classifier, SVC. This is for sure. We need the classification report confusion matrix to look for the classes at a more deep level. This is train and test split to split your data. Now we are just checking if there is a no not null value in this one, and we are only considering this feature as a X feature. I told you we are only going to use 2 features today. Now you might thinking we have a 40 features. Why you are thinking again? I'm repeating. This is a text classification problem actually. Okay, this is not normal multi-class classification. For text classification, other feature doesn't matter. Okay, only matters the review comment message, because this is we need. Out of this, based on this, we decide whether the customer is giving positive feedback, negative feedback, or neutral. Okay, and then we are spreading the data set here. This is a label encoder. I'm using this because I wanted to plot the confusion matrix. And then I'm creating the empty dictionary here. You will understand why did I created it. Okay. First of all, we will start with the logistic regression. Okay. So the logistic regression, as I told you, this will give you the probability of happening something. If customer is giving the positive feedback, then it will tell you probability of the customer is giving the your positive feedback 90%, 95%, 80%, something like that. And then we will declare here with the TF-ID vectorizers. So we will set this one, and then we are applying the logistic regression model. You might thinking why I'm applying this. Okay, so here I will give you the explanation about it. Here, this one, we will copy this one. Okay, So you can also like search it like this way. Okay. So TF-ID vectorizer in this feature extraction text is a powerful tool for converting raw text document into matrix. Okay. And this is called TF-IDF. The full form is term frequency inverse document frequency. This is we need. Why you need it now? Because you are working on the text model building, right? And you are going to input feature. Which input feature you are going to use? Review comment message. This is all comments. There is a no numeric value, all text. So you need to use this one. This is the reason, okay? And it combines the functionality of count vectorizer and TFD transfer into a single class, streaming the text processing pipeline for this one, okay? So how it works? It first tokenize the text document, breaks them down into individual words, separate them. Like there are many connecting words, keywords too, to and e and are into, right? And there is a one like the words too, like if you're writing the product starting with the title letter and you are writing the product keyword with the lowercase too, so it will not treat them the different, it will treat them equal. Okay, this is the biggest advantage of using it. And then it calculates the term frequency, TF, for each term in each document. TF represents how frequently a term appears within the specific document. So you can see how it is converting your text data into the vector form. Okay, and then what is inverse document frequency? It then calculates the inverse document for each term. It measures the importance to term across the entire corpus documents, and then terms that appear many documents as a lower IDF, inverse document lower IDF, while terms that are unique in few documents have a higher IDF. So this is assigning some value actually. Okay, so in this, and it also, this is the key features of this one. Okay. Now you can see here, if I will make you the, let's look at this a small example. So look at this. This is the first document. The document is the second document. Now you can see document keyword is coming many times, right? And if you are converting into the vectorizer and you are fitting onto this, and then you will print it, then how it will look like. Let me copy this one and let's do the experiment. Okay. So you don't do it. I will delete it. I'm just showing you. Okay. So let me run this. Look at this now. So this is what it is doing. It is first we are creating the instance of this one. Then we are fitting and transform the document onto the this one. Okay, vectorizer, the instance on this. And then we are getting the features name and print the matrix and then convert into dance. Now look at this. This is your with the 21 stored elements and shape. Here it is telling the values of each codes, how many times these are happening. Okay, and this is the matrix. So this is the result of your whole text document, this one. Okay, this is the same is happening which model we are going to apply it. This is how the TF ID vectorizer working. And this is the best way. Whenever you don't understand anything, just Google it like this way. You can see we have the example too, and it is explaining very well. It is also explaining the features too, how it is working. Okay, so this is about your like TF ID vectorizer. Okay, and now we will jump here. Here we are just setting the 5000 like the iteration or the sorry, we are not iteration, we are picking up the words. Okay, you can increase and decrease, you can see, because we have a very big data set, it was taking too much time, so I have considered the 5000. If you want, you can increase, decrease and see the changes. Okay, and then we will create the pipeline to fit onto the X train, Y train text data. So what is this? This is the data which we have, like variables which we have created when we have splitted the data set. Okay, and then we are just doing the prediction. This is very simple, right? And then I'm storing my accuracy into this text result. Now, did you does it make sense why I was declaring this one? To store my result, because I want to create the data frame at the end of this video to show you the different model accuracy together, so you can do the comparison. So in the part third, we can do the evaluation for the model which contains the highest accuracy. Okay, and then we are printing the classification report. You have seen many times in my videos, right? This is the same I'm doing. Then we are plotting the heat map. Now look at the result. So I hope everybody know now how to read the classification report. We have a precision, recall, F1 score, sport, right? So you can see the negative. This is the precision. This is for neutral, and this is for positive. It is showing for each class. And then you can see here, this is the actual, like the values, and this is a predicted one. So actual positive, here it is showing you, we will consider, because in the multi classification we need to consider first this portion. Okay, this is the way how we read, and then this one. Okay, this is the way how we read the multi-class classification. Okay, and you can see your total, like the positive classes, it is able to like predict correctly 17,114, right? And the actual positive classes, if you want to consider, right? This is the, okay, I think I have drawn this line incorrect. Just give me 1 second. Let me clear all drawing. Okay, so whenever you are reading the multi-classification, either you can look at like this. Always read it diagonally actually. Okay, and then here the actual positive in this, let me clear this one, and then we will consider it here again. So look at this. So this is the correct value. Rest all are errors. Okay. So you can see row wise, it is showing the actual value row wise, and column wise predicted one, the what the model predicted. So it is showing, it is like the actual negative here. It was able to predict 2245. Okay. And how many positive classes it was able to predict correctly? 17,114, and neutral 84. But if you look at this one, this is 17,000, this is 2. So it is more towards the positive class. This means logistic regression is working very good, and or you can say biased towards the positive class. So it is more telling us the customers are giving more positive feedback. We want this, right? As a stakeholder, if you have the business, you want to look for this feedback too. But you can see it is not able to predict like too much or at a deeper level. Only 84 classes it was able to predict at, sorry, as a neutral, right? And negative classes it was able to predict only 2245. Okay, so this is the way you need to look at the multi-class classification. This is a result of multi-class classification. And if you want to go with the accuracy, here we can see the accuracy, it is giving us 86%. Okay, now let's look for the another model too. Before moving ahead, I have just drawn this graph, which top features your logistic regression model has used during the model building. This is the best graph, and this is the best way to come to know which features are like the your model is using during the trained of the model. Instead of this, this is not a feature, although I will say this is the keywords because we are only using the one input feature. If you want, we can just say here top keywords, right? You can also write it this one. This is a Portuguese language. This is not a normal English language. Okay. So that's why it's a hard for read. But this is telling us which keywords it has used most of the time. You can see this is a coefficient value, and this is negatively. This means these keywords alarm, super, this one 10, this is like pushing the model towards the negative sentiments. It is helping the model to predict the negative feedback, helping the model towards the negative your results coefficient value, and this is positive, these keywords. Okay, and you can see here too. Okay, this is new, this is for negative class, and this is for your neutral class, and this is for positive class. Okay, because each keyword is contributing negatively, right, towards the your negative comments, right, sentiments. Which words those are? These one. This is contributing, like the model, it is not pushing the model towards the predicting correct negative sentiments. It is just like contributing negatively to predict the negative comments, pushing towards the negative results. Okay. So here you can see this is because this is coefficient value is negative. But here you can see the coefficient value is positive. This is helping the model in a positive way, positively, to contribute or classify the negative comments. This means if some person says, give the comment, the product was poor, right? So it is helping the model to classify the comment as a negative in a positive, like the helping, contributing more, in short, I will say, as a layman. Okay. So this is pushing the model towards predicting the correctly the negative feedback. And this is the for the negative one. And now this is the same for neutral class. These are the keywords pushing the model towards the like the neutral comments negatively, and this is positive contribution, and this is the same for the positive comments. Okay. So this is a little bit hard to understand at a beginner level, but you will understand by the time if you use these graphs every time for your every model. It will help you to like understand which model is pushing the model towards correctly predicting the classes, and which features or words helping the model to not predicting or classifying the your target feature positive, negative, or neutral correctly. Okay. So based on that, we draw this graph. So this is very, very useful. And you can also decide and you can remove like keywords which does not have a much contribution, and then you can check the output or accuracy again. That's why we draw this one. Okay. And then we will talk about the sport vector classifier. I have already explained like on the whiteboard. So here we are again going to pick up the here maximum your features or keywords you can pick up. SVC model, you need to import linear SVC. Prediction is same. We are saving it into the dictionary for our later on. So we can use it. And now look at the result. Now look at this one diagonally. It is more giving good result in the negative, right? Let me check previously how much. This is, I remember, this is 17,1142245, right? So here neutral value is also comment is classified more good than the random logistic regression, right? But this is decreased, right? And this is also increased. And let's look at the accuracy too. What is accuracy? 86%. So it is giving the less accuracy than the logistic regression in this case, right? So now we will move ahead again to print the features name. This is again we are printing linear SVC using these keywords. Okay, logistic regression was using something else keywords. Look at this. So every model has a different way to use the keywords, right? So this is good to draw and understand which keywords was used by most of the time negatively, positively, which pushing the model towards the correct prediction or classifying the sentiment of the customer positive, negative, and neutral. Okay, so this is very good. And now if we go with the next model, random forest. This is my favorite one actually. An estimator 100 and random forest. This one we are again creating this. And then now look at the result. This is 17,149. This is much better. This is 22329, 280. Very good result, right? So it is increasing. And top 15 feature importance means of top 15 keywords. So I will correct it. Keywords, because we are only using one, right? It will take a few seconds because random forest I have ran it. So let it be run. In the meantime, we can discuss about the AdaBoost. Then I will show you the output of this one, okay? Because we have it will take few seconds. Okay, so AdaBoost is what we learn from the week trees, right? And then look at this result. This is lower, right? 17, 16, 14, very low. It is not giving good result, right? So its accuracy, we can see the accuracy. Its accuracy is also 82%. It is random forest is still running. So let it be run. So what the top 20 keywords this model is using, it is giving the list of this one. So this is using most of the time. Now 20 more than 25%, but the least keywords which is using these one. Now if your choice, you can filter or strip off these keywords using your string methodology or any other methodology which we can apply to quickly remove these keywords and then fit the model again. It might increase your accuracy. This is called evaluation. Okay. And now let me see, this is still running, random forest is not showing still. So now look at the XGBoost. This is also good, this is also good, but this is again decreased, right? And top of the 20 top 20 keywords it is using, or the feature importance you can say, this is a keywords using. But did you notice the XGBoost is using like the keywords many, right? It's a different, but it is using many keywords. And now if you look at the accuracy of this one is 86% for the XGBoost. Okay. And then here we are doing the comparison actually. Okay. So random forest, I have ran it previously too because I have the accuracy at the end. I wanted to show you the comparison. Here I have created the data frame actually. That's why I was collecting the accuracy results in that one. If you look at this, the random forest accuracy is highest, 87%. I showed you, then I made the changes. Actually, it will take some time to complete the processing of the model. But this is the best way you can create the data frame and show it to, it is completed, the pre-process. So we will go back. Okay. Logistic regression. Sport vector. This is the random forest. Okay, so I have changed it to the keywords. Instead of features, you can write down the keywords. I used to write actually features, so I forgot about it. But here we are using the only one input feature, comment message. You can see now is used most of the time by the random forest. Okay, and the accuracy is highest accuracy is with the random forest. So out of use these 5 models, out of these, your random forest has the highest accuracy. Now, if you are at my place and you are working with this data set, might be numbers are different at your end. You might collect the data from somewhere else, or you might make some changes. Your analysis is different. Don't go with the numbers, just understand the logic actually. Understand the process, how I am doing from the start, step by step, what steps you should take. Okay, don't look for the numbers actually. Okay, so for me, it's a 87%. So this is the best model for me. But my job being a data scientist will not stop here only. Now, what will be the next step? Next step will be to evaluate this model. From 87%, I would like to make it 95%. I would like to make it 90% or whatever best I can do. So how you will do that? By evaluation of the random forest. Now in my part third, we will discuss the how you can hyper tune your random forest model to increase the accuracy of the model, and then you will learn how you can pick up the best model and you can make it by evaluating it or by hyper tuning it, you can increase the accuracy. Number 2, you will learn the different ways to hyper tune your random forest model. So stay with me. This was all about our today's video. This was very easy because I used to tell in my each video, model building is not a rocket science. Okay, because model building means you are just fitting the data. So now till so far I have made so many videos. I hope you would understand now what is the most important processing point for the machine learning. Data analysis. Okay, if your analysis of the data is good, your model is automatically going to be good. It's a simple logic, right? If you are learning correctly before the exam, you are following each and every step, you are making notes, you are like understanding the concepts from small micro concepts to big concepts, right? If the questions come like we used to say out of syllabus, or we used to say, you can say like this question, I have never read this topic, but that was just twisted question. If you have done your homework, your preparation properly, you will never fail in the exam. Same with the model. If your analysis is good, your model can never be fail. Okay, and after building model, being a data scientist, your job duty is look for the feature importance, or you can say keyword importance. Okay, as I told you, right? And then for like the your this one, we will work in the part 3, how you can hyper tune your model, random forest. Okay, again, if I connect it with the layman example, once you are done with the internal exams, if you think you got a 75 marks out of 100 marks, now in final exam, what you want to do? You want 100 out of 100, right? This is we will do in part 3. Okay, so now stay with me, keep learning, keep patience. Happy science, data science. I will see you in the next video. Thank you so much for watching this video, and thank you so much for your support. Keep commenting, keep asking questions. It motivates me to make a more videos. Definitely I will try to be continuous. Again, I was too not well, I was not well, so this was the reason, but definitely I will keep uploading more and more videos. Thank you.